if we take the derivative of a product of functions with respect to x, the product rule tells us that this would result in the first function times the derivative of the second plus the second function times the derivative of the first. And then if we integrate both sides with respect to x, then we would integrate uv prime with respect to x plus integrate vu prime with respect to x. And on the left side rather, we have uv, and on the right side we can write v prime dx just as dv, and we can write u prime dx just as du. Now if we were to solve this for the integral u dv, we would wind up with a pretty handy little property here, and that is if I have a function times another function that appears unrelated, and I want to integrate that product, I can do that by finding the function that dv came from by integrating that function and getting a function v, and then multiplying that by this function u, and then subtract from that the integral of that function v times the derivative of this first one, u. So let's look at an example. Let's suppose that we're supposed to integrate 3x cosine 2x dx. So we have this function cosine 2x, and we have this function 3x, and they appear a bit unrelated in terms of functions and their derivatives. So what we would want to do then is identify a dv, one of these functions, as a derivative of another function. Now we're looking through here and we're saying, okay, well, if I were to integrate 3x, I'd wind up with 3x squared over 2, and I'm not seeing an x squared in here. So we're going to pick on cosine 2x dx as our dv. Now, according to our derivative properties here and our integral relationships between sine and cosine, if dv is cosine 2x dx, then v is going to be 1/2 sine 2x. And we can verify that just by doing the chain rule on this 1/2 sine 2x here. Derivative of the sine of 2x would be cosine 2x times the derivative of the inside function, which would be 2. Multiply that by the half, and I'm just going to wind up with cosine 2x. Now, if dv is cosine 2x, then u must be what's left, 3x. So u then is going to be this 3x function, and that would leave du to be 3 dx. So what I'm going to do then is take this expression that I have here. We've got u identified as 3x and dv identified as cosine 2x dx. And I'm going to say, well, that's equal to u times v. Okay. So u times v is going to be 3x times 1/2 sine 2x. So there's u times v. Now I'm going to subtract from that the integral of v du. So v is going to be 1/2 sine 2x, and then du will be 3 dx. So now what we need to do is think about, well, what would happen if we integrated this 1/2 sine 2x 3 dx expression here? And we remember that the integral of the sine of any constant times x dx is just going to be minus cosine that constant x over k plus c. So we have our 3x, and we start thinking about this and thinking, you know what, we could multiply some of this out a little bit. We could call that 3x over 2 times sine 2x minus, and now when we integrate this, we might think about pulling the 3/2 out front and make it look a little bit more than like what we've got here in our little formula. So 3/2 integral sine 2x dx. Okay, so this is going to give us 3/2 x sine 2x minus 3/2. Now, when we do this integration here, we're going to have minus cosine 2x over 2. And that'll be plus some constant. So we can simplify this a little bit. Let's see, we have 3/2 x sine 2x minus, actually this is going to be plus now, plus 3/4 cosine 2x plus our constants.